Hello my friends, in today's video we are given a square ABCD. We construct this blue angle equal to 15 degrees, construct also another angle also equal to 15 degrees, extend these lines until they meet at point E, form line segment AE, and now if the side of the square is given equal to 2, we need to find the length of line segment AE. So let's begin. Focusing on this white triangle, we can see that it has two angles both equal to 15 degrees. Therefore it's isosceles. Now from point T we extend segment EC until it meets line segment AD at point F. Observing this green angle, it's an external angle of the white triangle. Therefore, it's equal to the sum of the two remote interior angles. So it will be equal to 30 degrees. Now, this yellow angle, together with the blue angle of 15 degrees, must be equal to 90, because ABCD is a square. From that, the yellow angle can be calculated to be 75 degrees. Observing this white triangle and using the fact that the sum of its interior angles must be 180 degrees, we can find the missing angle. We can see that this triangle has two angles both equal to 75 degrees. Because of that, it's isosceles. Now, the most important part for solving this problem is to observe that this gray angle which I just formed seems to be equal with the green angle of 30 degrees. So for me, the objective from now on becomes to prove that this must be the case. Now, in situations like that, where we want to prove that two angles are equal, there is a general method which can be applied, and I will show it to you right now. This method is based on the alternate segment theorem. So let's start remembering this theorem for the time being. Suppose we have this circle and line TQ is tangent to this circle at point Q. We construct a chord QR which has a common endpoint Q with the tangent. Now on this white side of the circle, we choose a random point P. Construct these lines, and what the alternate segment theorem tells us is that this blue angle which is formed by the tangent line and the chord must be equal with the yellow angle. Now, if you think about it, this theorem is very useful. Why? Because these two angles have vertex points, the white points, lying in completely different positions, and they also open up in different directions. Nevertheless, these two angles are equal because of the alternate segment theorem. Also, note that point P can be anywhere on this white side of the circle, as you can see. Each measure, I mean the measure of the yellow angle, will always remain equal, because this inscribed angle will always be intercepting the same arc QR. Now, how can we apply this useful theorem to solve our original problem? What we do is that we construct the circumcircle of this white triangle. Now I just make some labels white so we can see them more clearly. And the objective becomes to prove that the white line is tangent to the circle. If we manage to do that, then we will just apply the alternate segment theorem and we'll find that the gray and the green angles will be equal. So how do we prove that the white line is tangent? We construct the diagonal AC and from point F we bring a perpendicular to this diagonal which intersects it at point G. Now the white diagonal forms a 45-degree angle with the green side of the square. Therefore the brown angle must be equal to 30 degrees because the brown and the blue angle must be 45. That's why. Now, focusing on this white triangle, we use the fact that sum of its angles must be 180 degrees and we find the measure of the remaining angle, 60 degrees. We can see that point E is the midpoint of the hypotenuse. Therefore, if we construct the median to the hypotenuse, according to a geometric theorem, it must be equal to half the hypotenuse. Also, this dark green line must also be equal to half the hypotenuse because the original white triangle is a 30-60-90 triangle. Now, focusing on this white triangle, we can easily see that it's equilateral. Therefore, all its angles must be equal to 60 degrees. Angle AFD is 180 degrees and it's equal to the sum of the greenish angle which I just formed together with the dark blue and the yellow angles. From that we can find its measure to be 45 degrees. Observing this white triangle, we again apply the fact that the sum of its interior angles is 180 degrees. And we find the measure of the remaining angle, which in that case will also be 45 degrees. So this triangle will have two angles both equal to 45 degrees, and that's why it will also be isosceles. If we observe now these three white lines, we see that they are all equal. Therefore, point G is equidistant from 3 points A, F, and E of the circle. Because of that, according to a geometric theorem, point G must be the center of the circle. Now, the blue and the white lines form an angle of 30 plus 60, which is 90 degrees. Therefore, these lines are perpendicular. And also note that the blue line passes from the center of the circle. Because of that, the white line is tangent to the circle. So we just proved what we wanted to show. And now we just apply the alternate segment theorem and find the gray angle to be 30 degrees. Let's remove all the unnecessary lines to see more clearly. And in this white triangle, again the sum of its interior angles is 180. So we calculate the remaining angle to be equal to 75 degrees. we notice that two angles of this triangle are both equal to 75, therefore it's isosceles. At the beginning of the video we were given that the side of the square is equal to 2. Therefore, because this triangle is isosceles, we find the measure of AE to be also 2. This was the proof. Thanks for watching this video and I'll see you on the next one. Take care.